Hey, hey! So today we're going to do our polynomials lesson. We're going to talk about the leading coefficient test. So I'm going to walk you through this. So I posted the notes on Classroom for you to look at and walk through it with me. All right, so hold on, here we go. So we've got the leading coefficient test here. And basically it helps us to determine the end behavior. So you have all this in the notes that I posted as well, so you can look at that. So let's go through the first couple of options. So this is basically a chart that goes through all the different rules for you. So if you look along the first row, that is when your end value or your exponent is odd. If the exponent is odd, that tells us that the end behavior or the arrows are going to be pointing in different directions. Looking at the columns here, the first column here is if it's a positive leading coefficient. If it's a positive leading coefficient and the end behavior is different directions, that means it has to end positive. So if it ends positive on the right-hand side, you know the arrow's going up. On the left-hand side, you notice the arrow's going down. Now, the center of the polynomial is dotted because we don't actually know what's occurring there. It could be different depending on the function that's given. The one to the right of that is if you have a negative leading coefficient. If you have a negative leading coefficient, that means that it has to end negative. So you notice on the right-hand side, because remember you're always ending on the right, you notice that it is ending down negative. That means that if they're different, then obviously on the left-hand side, it has to be starting up. So I write, okay, well, it goes from positive to negative. Once again, the inside changes depending on what function you're given. The next row is if your exponent is even. Let me move it down. If your exponent is even, that means that the arrows are going to be pointing in the same direction. So if you look at the first column, we notice that you have a positive leading coefficient, which means it's going to end up. Well, if it ends up, it has to start up as well since they are the same. The one to the right of that, noticing that the leading coefficient is negative, which means it's going to end down. Well, if it ends down, it has to start down as well since they have to be the same. All right, so we're going to go through some examples, and you have all of this in the notes that I sent out. Once again, more examples of even meaning the same direction. Notice that these are both facing down, and I asked the question, well, why are they both facing down? And the answer to that question is because they both have negative leading coefficients. On the right-hand side, you notice that they are odd. Well, they are odd because if you notice the arrows on the left and the right-hand side for both of them, they're going different. This first one is ending positive, which means that the leading coefficient must be positive. The second one is negative, which means that the leading coefficient there must be negative. Now, we remember the way that end behavior has to be written. As x goes to positive infinity, f of x goes to, and as x goes to negative infinity, f of x goes to. That's just where the arrow's pointing. Well, if I'm going to positive infinity, that means to the right. As I go to the right, notice the arrow's going up, so f of x is positive infinity here. As x goes to negative infinity, so as you go towards the left-hand side, you notice the arrow's going down, so that means this one's going to be negative infinity. So let's go through a couple examples as to why this happens, and I'll walk you through it. I'm just going to put you up. I got this, cool-looking contraption here, so I'm going to hold on my phone. Give me one second. So let's walk through this one. So we first always look at the exponent, and the exponent, if we just have y is equal to x, the exponent there is 1. So we say, okay, even or odd. And I know that the number 1 is an odd number, so I write odd. Well, if they are odd, that means that they are going in different directions when we're talking about the end behavior or the arrows. Well, if they're going in different directions, I need to figure out, well, how are they starting? Or how are they ending, rather? So I look at the coefficient. The leading coefficient there is also 1. 1 is a positive number in the front. Well, if it's positive, that means it must end positive. If they are different, that means it has to start out negative then. Because if I wrote positive, then that means they're the same, but they're not the same, they're different. So this one's going to start out negative and then go to positive. Well, think about why. This is y equals x. We know that that's just a line, right? So if we were to graph this, essentially you're starting out at the origin, right? You're going up 1 over 1, up 1 over 1, up 1 over 1, and down 1, left 1. So you're really just going to have this line that looks like that, right? And as you read from left to right, noticing on the left-hand side, it's going negative, down. And then on the right-hand side, it's going positive, up. So that's where it comes from. Let's do the negative one. Looking at this one, we have y is negative x. We first look at the exponent, and the exponent is 1. Well, 1 is an odd number. And odd means different. So we know they're going to be going in different directions. We then look at the leading coefficient, and the leading coefficient here is negative. that means we are ending negative. Well, if we're ending negative and they're different, that means it has to start off as positive. Let's think about the graph here, right? We know that we're crossing at the origin, and the slope there is -1/1. So down 1, left 1. Sorry, down 1, right 1. I don't know why there we go. Down 1, right 1. And then up 1, left 1, up 1, left 1. I know you hear the baby in the background. Okay, so it's going to look something like that. Look at the slope. The slope is negative there, right? So thinking about it like this, we know that it starts off positive, so positive is here, and then ends negative here. So that's where it comes from. Let's look at higher exponents now, since we're getting to our polynomials chapter, which has higher exponents. So the exponent here is 2, and that's an even number. Well, even means same, right? So they have to end in the same direction. I look at the coefficient here is positive. So I have to end positive. Well, if it ends out positive and they are the same, that means it has to start off positive as well. So positive to positive. Well, think about y. We know y equals x squared really is just a parabola. It looks like this, right? It's a parabola. Noticing it's ending positive and starting off positive, right? Both end behaviors up. Let's look at this one here. The exponent is even, which means same, right? The leading coefficient there is negative, so it has to end negative. Well, that means that it has to start off negative as well, right? If they are the same. We'll think about what this one looks like. You know, it's a parabola. Vertex is at the origin, and it's down, right? So it looks like this. On the left-hand side, it's going down. On the right-hand side, it's also going down. Okay? Let's get into higher order polynomials. So when the exponents are higher. So if we look at something like this here, we have negative x to the third, and then plus 4x. So something like this, we always start by looking at the leading coefficient as well as the degree of the polynomial. Well, sorry, the exponent here is 3. That's the highest exponent. 3 is an odd number, right? Well, if it's odd, that means they're going to be different directions. If they're different, I have to figure out, well, where are they starting and where are they ending? So we always look at the leading coefficient. So that's the coefficient in front of the highest exponent, which is minus, which means it's ending down. If it ends down and they're different, that means it has to start off positive. Well, I'm not expecting you to know what this graph looks like, but if you plug it into your calculator, you'll be able to see. But basically, it's going to be looking something like this. On the left-hand side, it's going up, and on the right-hand side, it's going down. So something like that when you plug it in your calculator, okay? So notice on the left-hand side, it goes up. On the right-hand side, it goes down, right? And then you could write it in the proper notation if you needed to. So as x goes to positive infinity, f of x goes to. And as x goes to negative infinity, f of x goes to. Well, as x goes to the right, positive infinity, notice it's going down. As x goes to the left, right, notice f of x is going up. So positive infinity, which makes sense here. Positive is to the right, it's going down. On the right side, we have a negative. Negative is to the left. On the left side, we have a positive, which means it's going up. Let's look at this one here, x to the 4th. So the highest exponent here is 4. 4 is an even number. If it's even, I know that means it's the same. So the directions are the same. We'll have to figure out where is it starting and where is it ending. So I look at the coefficient. The coefficient here is just a 1. It's a positive number, which means it's ending positive. Why is this phone shaking? Hold on. Maybe that's better. Okay, which means it's ending positive. Well, if it ends positive, it must also start out as positive since it is the same. Okay, so let's think about what this is. Now, this is something to the 4th power. I'm not expecting you to know what it looks like, but it does look like a W. So it looks something like this. If you plug it in your calculator, you'll be able to see that. Noticing positive, up, and up. both ends are going to positive infinity. So if you were to write it out in this notation here, this would be positive infinity, and this one would also be positive infinity. There's one more I want to do before I give you a challenge. So give me 1 second. Let me just erase this previous board. And stop shaking. Okay. We'll do C, which is f of x is equal to x to the 5th minus x. Okay, so remember, you're looking at the highest exponent. The highest exponent here is 5. 5 is an odd number. Well, since it's odd, that means different. They're going in different directions. Okay, so I need to figure out, well, where is it ending? I look at the leading coefficient, and the leading coefficient here is 1. It is a positive number, so it's ending positive, which means it's starting off negative, since they're different. Now, once again, I don't expect you to know how this one looks, but on the left-hand side, it's going down, and then on the right-hand side, it's going up. It actually kind of looks something like that, but you can plug it in your calculator to see. Okay, but I don't really care about the middle. As long as you know on the left it's going down and on the right it's going up, something else can be happening in the center. I don't really care. So if we wanted to write this in the proper notation, as x goes to positive infinity, f of x goes 2. And as x goes to negative infinity, f of x goes 2. So as x goes to the right, look at the right-hand side that we wrote here. It's positive, which means it's going to positive infinity. And as on the left-hand side, as it goes to negative infinity, on the left we have a negative sign, so negative infinity. And that makes sense based on the graph there. So here we have our challenge problem now, okay? Our challenge, we've got f of x is equal to 5 plus 3x minus 5. Okay, that looks terrible and it doesn't fit. Okay, let me write it down here. 5 plus 3x minus 5x to the 25th. Okay. So for this one, you're looking at the highest exponent. Notice I do not give it to you in the proper order. So if you want to rewrite it, that's fine. I'm just going to leave it like this. And I'm going to look at my highest exponent. And the highest exponent here is 25. Well, 25 is an odd number. And odd means different. Okay, so I need to figure out, well, where is it starting and where is it ending? So I look at the leading coefficient. Now, the leading coefficient is always in front of the term with the highest exponent. So I'm really looking at this number here, which is negative 5. Well, that's a negative number, which means we're ending negative. Well, if we end negative, we have to start out positive. So there's our end behavior. Now, if we wanted to write it in the proper notation, f of x goes 2, and as x goes to negative infinity, f of x goes 2. Now, honestly, I have no idea what this graph looks like. I would have to plug it in my calculator, but without plugging it in, I know where the arrows are pointing. On the left-hand side here, so that's as you go to negative infinity, it's positive, so positive infinity. And as you go to the right-hand side, so positive infinity, notice that there's a negative sign there, so negative infinity. So know what the arrows are going to look like. On the left-hand side, it's going to be going up. On the right-hand side, it's going to be going down, and I don't know what's happening in between. And that's it. All right, so I'll post some practice questions for you to work on Classroom Next.